Hey all you math heads! Today we're going to cover some triangle trigonometry. We're going to be going over what triangle trigonometry is and some examples of how to use it and how it is useful. Alright, so first of all, we need to understand what triangle trigonometry is. So let's get right into it. First of all, what is a triangle? Well, the dictionary would define it as a polygon with 3 edges and 3 vertices. It's one of the basic shapes in geometry. And yeah, that is pretty much it. But we do see different types of triangles based on different side lengths or different angle measures. And that will affect the math or trigonometry we do with these triangles. Now, moving on to trigonometry. So, what is trigonometry? Well, it's a branch of mathematics that studies relationships between side lengths and angles of triangles. Basically, all math that has to do with triangles is trigonometry. Little vocab for you. This is called theta. It's what we use to call an angle measure that we don't know what degree or radians it is. So moving on, let's get into doing some trigonometry. All right. First of all, we have a pretty simple equation here. So ponder the triangle ABC, where AB is 16, angle A is 22 degrees, and angle C is 43 degrees. So we need to find the missing angle, find the length of BC and AC, and find the area of the entire triangle. Now, first thing you want to do always is draw the triangle. Doesn't have to be accurate, just has to be a triangle. And then you want to label your sides and your measures. AB, 16. Angle A is going to be 22. And C, 43. Now, first of all, find the missing angle. We know all triangles add up to 180 degrees. So, if we add 22 and 43, we get 65. So, if we take 180 and we subtract 65, we will get our unknown angle. So, plug that in your calculator, or solve in your head if you're really smart, and we get 115 degrees. So now we know B is 115. Simple enough. So now we need to find the length BC and AC. Now we don't know those lengths, we only know AB. But there's a pretty simple trick you can use to solve these. It's one of my favorites. It's called the cosine. It's called the sine rule. Cosine rule is something different. So here, I'll draw it out for you. So A over sine of A is equal to B over sine of B, which is also equal to C over sine of C. Now you can flip this around, invert it, put it in any order. It's a pretty good rule of mathematics, and it will help us solve this problem. So I'll show you in action. Oh, first of all, the lowercase a represents the side on the opposite of A. So right here, this would be lowercase a, this would be B, and this is C. So that simplifies it a lot. Alright, so 16 over sine of 43 is equal to A over sine of 22. Now we're going to want to isolate the variable, the unknown. So we're going to want to multiply both sides by sine of 22. Now you're going to want to plug that into your calculator. And you'll find that A is equal to 8.7, yada, 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 yada. You're just going to want to do 3 sig figs. So, like that. But if you're going to want to use this again, you're going to want to use the whole thing as it is in your calculator. You want to be accurate. Alright, and now for the last one. Let's use 16 over sine of 43 again. This is one of my favorite math rules. So versatile. Alright, and we need to solve for b. So, it's going to be the sine of 115. And again, you're going to want to multiply by sine of 115. The cool thing about this is if you flip it around and you know the side lengths, but not the angles, you can use it to find the angles. So versatile. Alright. So, you'll find that b equals 21.3 if you round it up. Alright. Now, we need to find the area of the entire triangle. Now, if you have a right angle, then you're going to want to use the height and the base to figure it out. But because we have a obtuse angle, we're going to want to be using a different formula. So this area of a triangle formula works for any triangle, and it is pretty simple. It is a area equals 1/2 AB sine C. So you're just going to be multiplying all that together. In the calculator, I personally like to use 0.5 because it's easier. So we know A is 8.79, B is 21.3, and the sine of C would be the sine of 43. But when you put this into your calculator, you're going to want to use the whole thing, the whole number, because we've just rounded and we want to remain as accurate as possible. Alright. So, once you put that in your calculator, A should equal 63.7 ... 3 sig figs. So, yeah, that should be the area of the entire triangle. So, that's going to be a wrap on this problem. The next one is going to be a bit trickier. Alright, so moving on to our real life scenario, a practical application for these maths. So, situation is Javen and Meliza are in a competition to see who has the larger triangle. But alas, not all is known about either Javen's or Meliza's triangle. Luckily, we can use the power of math to determine who wins the contest. So, looking at these triangles here, all the information are already contained within them. So, first thing first, Javen believes that the larger triangle is determined by having a bigger height. Silly Javen. Find the unknown length in Javen's triangle. Now, before we do that, Great Man once told me that you should read the question ahead because it can help you solve this one. So, after Javen proclaimed his victory, Eliza points out that you determine the larger triangle by finding the area. Find the area for each triangle and determine a winner. So, because Javen apparently won, in his mind, that must have meant that he had a bigger height. So, we know that right here, this length has to be longer than 11 because he thinks he beat Malizer. Alright, so because we have right triangles, that allows us to use the Pythagorean theorem. A squared plus b squared equals c squared. Alright, it's one of my favorites. So, because we're not trying to solve for c, because this would be the length c. Normally, we have JAV and MIL. You can reformat the Pythagorean theorem to suit your needs. So, since we're trying to find, this would be lowercase j, this would be lowercase a, and this would be lowercase v. So what you can do if you're solving for lowercase j, or if you're using ABC, it would be lowercase b. We can reformat it like this. B is equal to the square root of c squared minus a squared. And that would be b equals square root of 13 squared minus 3 squared. Now, plugging that into your calculator would give you 12.6. And that decimal goes on for a while. So we know that this is 12.6 and some are approximately 12.6. It's an easier way to write it. So we now know the unknown length, which was 12.6. So we know that Javen believes he won the contest, but he didn't. So now that information will help us solve part B. So after Javen proclaims his victory, Malizer points out that you determine the larger triangle by finding the area. Find the area for each triangle and determine a winner. Unlike the last problem, there's a different formula for finding the area in triangles that have a 90-degree angle, so right triangles. It's going to be area equals height times base over 2. So the base would be on the bottom, and the height is going to be this, right next to the 90-degree angle. And that'll get you the height of a triangle, which is pretty simple. So let's set this up, shall we? First off, Javen's triangle. So area is equal to 12.6, and we're going to want to put in the whole thing, times 3. And then we're going to want to plug that into our calculators, because we need the whole number and its decimal. So A should be giving us 7.59 going on. So just approximately 7.59. Now after that, we're going to want to solve Malizer's triangle. Oh, and almost forgot, never forget, ever, we want to use the measures. So m, meters, millimeters, whatever that means, right there, that's going to be m. And now this, our answer, is going to be m squared. meters, metres, whatever it is, squared. You can lose points for that in my math class. All right, now moving on to Malizer's triangle. I don't know if you're seeing a pattern here, but it looks like these numbers are kind of bigger. So if this was the ACT, you could predict, get it much quicker to figure out the answer. Okay, so plugging that into your calculator should give you 27.5. Wow, that is significantly bigger. So Malizer wins. Yeah, all right. So that goes to show that just because the triangle is bigger, you got to factor in the area. Learned a lot from this question. Very good question. All right, so that concludes our real non-life scenario. All right, thanks for watching. Be sure to like and subscribe for more. Shout out to Malizer, who made me did this. Love you, Malizer. You're a really good teacher. I wish I could go back to your class. But I hope you love this video. All right, bye.